So you can see here in this example 1, f of x is given as x squared plus 3, and you're being asked to check if that function f of x is even. And then you're asked to sketch it and see if it is symmetrical about the y-axis, because remember, that's the graphical representation of what even means. And we'll come to the graph. We'll come back to the graph at the end when I've finished the algebraic section. So again, this is the appropriate sort of setting out. It keeps you on track to answer the question, and it shows the marker that you understand not only the question, but what you need to do to answer the question. So you start off, a function is even if, and you state the property, f of x equals f of minus x. Therefore, or that is, f of x is given as this x squared plus 3. End of story. That's what f of x is. Now work on the right-hand side. And f of minus x would be sub minus x into that function. So it's minus x all squared plus 3. But when we simplify that, negative x all squared is exactly the same as x squared, and we've got plus 3. Now what do you notice about this and this? Notice they're the same. So we can say that this f of negative x is actually exactly the same as f of x. If you've been able to show that, you can conclude, and you do in your solution, include a conclusion. Therefore, f of x is even. Now, if we didn't know, for example, if we hadn't recognised that as a quadratic which graphs to be a parabola, and it's a nice easy parabola just being pushed up the y-axis 3 units, if we didn't know that, what we could do is graph a couple of points for x equals 0, 1 and 2, and then just reflect those points in the y-axis over here. I didn't draw the graph that way. I think most of us know now that from the algebraic statement, x squared plus 3, you recognise it as a quadratic, graphs to be a parabola, very simple parabola. The only transformation from the origin is it's been pushed up 3 units. I'll now do an odd example, and so it says check if f of x is equals x squared is odd. Just by the way, before I get to that answer, it's important to know that some functions will be odd, some functions will be even, and some functions will be neither. So it's not appropriate to for example, if you've shown that a function isn't even, so you've gone through the process for an even function and you found that it failed that test, it's not appropriate then just to automatically say, oh, well, it must be odd. No, odd or even are not the only two types of functions. So a function could be odd, it could be even, or it could be neither. And it's not until you've tested both odd and even and found they failed that you would actually conclude that the graph was neither odd nor even. Okay, so back here, is this function odd? Well, we start our answer. A function is odd if f of minus x is equal to minus f of x. So what I'll do in this case is I'll take the left-hand side and I'll work with it. Then I'll take the right-hand side and I'll work with it. And I'll see if they both end up equaling the same expression. I might just pause the video and write that up. Okay, so you can see there we've started off making the statement, a function is odd if, and this is the algebraic property. And like I said, the purpose of that is twofold. One, to keep you on track as to what you're doing. You're showing if the function is going to be odd using this condition. And two, you want to convince the marker that you know how to answer this question. So I'm going to take the left-hand side, which is f of minus x. I'm putting minus x into the function. It has to be squared, and a negative times a negative is a positive. X times x is x squared. So it just comes out at x squared. Now we can't go any further really with that. So this is when we jump to the right-hand side. We take the right-hand side, which is minus the function in x. So it's minus, and the function is x squared, minus all of that. Now minus x squared is just the same as minus x squared. The power is the higher operation there, so it'll hold tighter to the x. Now we can see that x squared and minus x squared are not equal. So we've got that the function in minus x, which gave us the x squared, and the minus function in x, are not equal. Therefore, we would say this function is not odd. Please don't assume it's even. We know this one in particular is, because it was the example in the previous page. But yeah, it's incorrect. Just because you show it's not odd, it's incorrect to say then automatically it's even, because it's possibly neither.